All right, so with section 8.2, this is dealing with one type of series, one type of sequence, one thing, period, and nothing else. This is only going to be dealing with linear style equations. Okay, so this is going to be the 2n plus 1, or the 3n plus 1, or the 3n minus 1s, or whatever. Okay, so these are going to be something that have a constant difference. And what I mean by constant difference is they are going to have the same first order difference. So if you remember what Ashton just said a second ago, where he said, so if it's the same after one time, then we'll use linear. That's what this is. So what we just talked about, where we subtract the numbers from each other and we have the same first order difference, it's linear. All of these are arithmetic series. Okay, so this is something like if I give you a series that looks like -9, -2, 5, 12, and 9. So if I have something that looks like this, the first thing I want to do is I want to tell if this is arithmetic or not. Now the way that I tell that is I subtract the right term from the left term. So I'm going to subtract -2, negative minus -9. I'm going to subtract 5 minus -2, 12 minus 5, 19 minus 12. So I'm going to do right minus left on all of these. Okay, -2 minus -9 is +7. 5 minus -2 is +7. 12 minus 5 is 7. 19 minus 2 is 7, and so on. All of these numbers are the same. Since all of those numbers are the same, that means that this is arithmetic. Okay. Easy check. Every one of these is going to be like this in this chapter, or in this section, sorry. Every one of these is going to be like this in this section. If it's not, the answer is it's not arithmetic, and you move on. Okay? So if you get one that they're not the same in this section, you just say, nope, can't do it, and then you move on. Okay? So an example of what that might look like is if I have 23, 15, 9, 5, and 3. Now this one, I would do right minus left. 15 minus 23 is -8. 9 minus 15 is going to give me -6. 5 minus 9 is going to give me -4, and then -2. Obviously, these are not the same, right? Since these are not the same, my answer would be not arithmetic. Right? So these are, this is not, I would move on. I wouldn't have to answer that question in this one because all I want to know about it are arithmetic series and sequences. Right? So this is a little bit nicer because you, one, know how to use your calculator for this. And number two, don't have to look too hard for a pattern. You have to subtract the numbers to see if they work or see if they don't. Okay? The other nice thing about this is it comes with a formula that you can use. And that formula that you can use will produce every single equation that you can deal with in this section. Okay? You have to find the things to plug into the formula, but it gives you a clear-cut formula. You know how yesterday, the day before, everything, we've been searching for patterns, we've been searching for ways to actually answer the question, and we might not be able to come up with it. If you can't come up with this one, it's only because you don't know what the formula is. The formula is AN equals A1 plus N minus 1 times D. Okay, the formula is like this every single time. You don't need to have anything in there for AN. This is kind of like your Y. This is kind of like your X. So AN is like the Y, N is like the X, domain and range, remember. This is just the first term, whatever the first term actually is. This is the number that you would be plugging in, and then this is the difference. So in the first example that we just talked about, the difference was 7. Okay. First example that we talked about, the difference was 7. So we'll go through an example of what these look like, how we can find them, how we can use them, but it'll actually produce every single one of these equations for us. Yeah.
Do you want us to memorize the equation, or is it going to be on top?
I don't know. I don't know. It depends on how mad you guys make me over the course of the time.
Well, it's before spring break.
And what kind of presents you give me, and you know, how many people bring me cool things. So like, you can always buy my affection.
What kind of stuff?
What if we?
Let's give him an unselectable thing.
A welcome mat. Oh yeah, I forgot about the welcome mat.
Just give them a
I'll probably give you guys the formulas. So I will give you formulas for Friday's quiz.
Small price.
I know.
And then give
All right,
them a
so let's
puzzle
find
and
this.
take one piece out.
We'll be looking up how to do it.
So let's write the rule.
Exactly. Yeah, you're right. Puzzle without these.
Mr. Shepherd,
What?
how mad would you be if you had a 10,000 piece puzzle and you're missing only one piece?
I would never put together a 10,000 piece puzzle.
You could probably like 3D print these out.
I actually saw a video. It was kind of funny. A dude was doing that and he was missing one piece. So they went out and bought the puzzle again so that he could have the
Oh,
piece to
no.
put in. And he didn't realize that they cut puzzles differently every time. Like, because however the picture goes in. So like the piece that he was missing was not the same shape as the piece that he was missing in the thing. So he spent like $60 on a puzzle that he couldn't finish. I guess he could have put the other one together, but I don't know if he did that. All right, so find the rule for the sequence. First thing we have to do is determine if this is arithmetic or not. Okay, so the first thing we do is figure out if this is arithmetic or not. The way that we're going to do that is just subtract these from each other. Most of you can probably see that because it's going up by 5 every single time. So the difference between everything is 5, which means that D is going to equal 5. Now, this is extremely important that you subtract the right one from the left one every time. Okay? Remember how in geometry or whatever, when you found slope of something, as long as you were consistent, it wasn't a big deal. This one, it is a big deal which one goes first. Because if I do 3 minus 8, 8 minus 13, 13 minus 18, I get -5 for my difference. That's not true. Okay? I want to do right minus left every single time on this. If you don't do right minus left, you are not going to get the right answer. So D equals 5. I'm going to plug this into the formula. AX equals A1 plus N minus 1 times D. Right? Now, one thing I want you to realize is your formula should have an AN and an N in it at the end of it. It should have that. That's what your formula should have. Everything else we can get rid of. Now, obviously, we can see that D is 5, so that gets plugged in there. And then you should be able to see that our first term in our pattern is 3. Tells you what we're starting with. So that means the first term in the pattern is going to be 3. Okay? So those are all the things that I'm going to plug in. Now I'm just going to simplify the pattern or simplify the expression. So AN is going to stay there. I'm not changing it at all. AN equals, we said our first term was 3 plus N stays there, minus 1, and then D is 5.
Wait, why did
Yep. Okay, so AN stays, should be there. A1 is the first term in the pattern, which is 3. N minus 1 stays there. The difference is 5. So now what I'm going to do is I'm going to simplify this to make it a like 3n plus 5 or 5n plus 2 or 2n minus 1. I'm going to simplify it just a little bit. And it's super easy to simplify because you just distribute the 5 through. You end up with 3 plus 5n minus 5. We combine our like terms and we end up with 5n minus 2. So the rule for my sequence is 5n minus 2. Okay. This is how all of them are in this section. Okay. They all can be rewritten as something like 3n plus 1 or 5n plus 2 or 6n minus 7. They can all look like that. Yeah.
so any time on test or anything, if it's arithmetic, just do that, and it will always work.
Yep. Yeah. They're the exact same. Arithmetic are all linear combination type questions.
So this equation can't work for the quadratic.
Correct. This would not work for quadratic, but it will work for every single linear. Yep. Because arithmetic and linear are the same thing.
So this is just basically the formula.
Yes, it's the formula for being able to find it if you didn't have your calculator. If you have your calculator, I'd honestly expect you to use your calculator for it.
This seems a lot easier.
It is. And that's the thing, because if you can find the pattern, this pattern is really easy because it's got a set, start, stop, everything in between. The other stuff, you have to find the pattern, which makes it more challenging. Okay. Now, the thing is, though, all of those questions aren't going to be quite that easy. Okay. They can give you different pieces of information. Like this one specifically says one term of a sequence is A19 equals -45. So this is telling you that one of the terms, the 19th term specifically, is -45. Okay? So it doesn't tell you anything about the first term, doesn't tell you anything about the second, third, fourth, all the way through the 18th. It tells you about the 19th term. And it tells you that the difference is -3. Okay? So it tells you this. And that's really all that you need. Because basically what I need to do now is I need to plug in a whole bunch of information to be able to find my sequence. Now, I'm going to do that the same exact way as I did the first one. I'm just going to be plugging different things in. Okay? So like my equation was AN equals A1 plus N minus 1 times D. Now, I've obviously still got this I can plug in, but I don't really have anything else. So what I'm going to do is I'm going to pretend that A19 is my nth term. Okay, so I'm going to pretend this is my nth term, which means I'm going to plug those things in to my formula. Okay, now it gets a little bit dicey on which one gets plugged in where, so I'm going to try to show you. Okay, this number right here is my n, because it's saying the 19th term. Now, if I want to figure out the 19th term, I would plug 19 into my equation, right? If I want to find the 19th term, I plug 19 into my equation. So 19 is going to get plugged in for n. Now, what is the 19th term of this sequence? It's -45. So since the 19th term of this sequence is -45, that's where that's going to go. Okay? But now if you notice, all I have left to solve is what my first term is. And that's what I need to be able to write an equation, right? In order to write an equation, I need the first term and the difference. This allows me to find the first term. Okay, so let's go through and let's solve it. So -45 is my 19th term. So -45 is going to go there. I don't know what my first term is. I know that -45 is my 19th term. And then I know that my difference is -3. Right. So now I'm just going to solve this for whatever A1 is. And once I solve for what A1 is, I can go back and plug it into my original equation. Right? So now I'm going to go through and multiply everything. Because my 19th term is 45. When I plug 19 into this equation, it would produce -45 because that is the 19th term. Okay. So Ashton's question is a good one. How do we know this is -45? This is telling me up top, the 19th term is -45. When I plug 19 into the equation, I get -45 out. Okay, so now we go through the whole math. And again, this is just maybe even 8th grade math solving for A1, right? So now this is 19 minus 1 is 18. So I'm going to get -45 equals A1 plus 18 times -3. So then I'm going to get -45 is equal to A1 plus -54. So I'm going to add 54 to both sides. So then I get what, -45 plus 54 is that 9. So that's telling me that 9 equals A1. And remember with my formula, I need A1 and I need D in order to fill this up, right? Fill out the entire formula. So AN is going to be equal to A1, which is 9, plus N minus 1 times the difference, which is -3. And I can again go in and start rewriting. Now, this is a nice question or a nice time to have the formula because your calculator won't help you with this if you don't have a list to produce your answer, right? So now I'm going to distribute this -3 here and here. So it's going to be AN is equal to 9, and then -3 times N is -3N. -1 times -3 is +3. So an is going to be equal to, I'm going to rearrange it as negative 3n plus 12. Give me a second to stare at it, make sure it makes sense. Okay, yeah. Far enough? And I'm going to give you guys one to try on your own to see that it makes sense. You good? 19 minus 1. Yeah, you're looking at it as multiplication. You good? Okay. All right, so I'm going to give you another one of these, same style. I really have no issue with the first type of question. I don't think that you guys would have a problem with the first one, but I just want to make sure that you can do this. Let's say that I give you A11, it's 43, the difference is. So I want you to try and do the exact same thing that we just did. Make sure that you know how to do it. I'm not giving you the first term. I'm giving you the difference. So you really have to find the first term. That's the goal. So we know our 11th term and we know our difference. So again, I'm going to use an equals a1 plus n minus 1 times the difference. And I know right now that the 11th term, when I plug 11 into my equation, I'm going to get 43. So when I plug 11 in, I'm going to get 43, right? So that's what we have. 11 gets plugged in, 43 is our output, all right? The difference, 5 goes here. So that gives me every variable I need except for A1, which is what I want, because I want to find A1, all right? So this one, and is 43. So 43 is equal to A1, I don't know, plus n is 11 minus 1 times 5. Now I can solve this equation for A1, and it gives me A1, and it gives me the difference, and I should have everything that I need. So 43 is equal to A1 plus 10 times 5, which is going to be 43 equals A1 plus 50. So negative 7 equals A1. Now again, that just gets plugged into the equation, but you simplify. So an is equal to A1 is negative 7 plus n minus 1 times the difference, which is 5. We're going to double distribute here. So we're going to get an is equal to negative 7 plus 5n minus 5. So it's going to be 5n minus 12. Little more straightforward than yesterday, because it's one type of equation, one type of pattern every time. Okay, so it's one type of pattern every single time, one type of equation every single time. It should be a pretty straightforward idea. Okay, there is one last thing that I want to show you today. And this is one that we're going to leave off with. We're probably not going to finish it today, but I wanted to show you so you can kind of get an idea of what it looks like. It's about the same level of difficulty as this. It's just an extra step. Okay. So this is the one that Alec was talking about, where if I don't have the difference and I don't have the first term, so this one says that A7 is 17, and it also says that A26 is 93. So I have to find a pattern that gets me from the 7th term of 17 to the 26th term of 93. What I'm going to do is I'm going to create two equations. So remember, my equation that I'm plugging everything into is an equals a1 plus n minus 1 times d. This time I'm looking for a1 and I'm looking for d. The only thing I could potentially know is what n is and what an is. Okay. So what I'm going to do here is I'm going to say that I know my 7th term is 17. I don't know A1. I know that in order to find out 17, I plugged in 7. So there's my first one. Again, I'm going to explain that one more time. The 7th term is 17, right? The seventh term is 17. So 7 goes in for n, 17 is what you get out, okay? Then I'm gonna do the same exact thing with the other side. So I know the 26th term is 93, so I'm gonna get 93 equals A1 plus, and then the 26 is the number I plugged in to find it, times D. And you'll now notice that we have two equations, right? That's what we have. If we have two equations, we can use a system of equations. Before you do the system of equations, simplify it, okay? Simplify this as much as possible. So this is saying the same thing as 17 equals A1 plus 6 times D. This is saying 93 equals A1 plus 25 times D. Now, do you guys prefer substitution or elimination? Okay, we could use either one. It doesn't make a difference at all. Doesn't change anything at all. Okay, so let's use elimination. So if I line these up, I'm going to get 17 equals A1 plus 6D, and 93 equals A1 plus 25D. It does not. Nope. It should not make any difference no matter how you do this. If you line up one equation with the other, if you did one equation before the other one, it doesn't make a difference. So what do we get? Are we going to add or subtract these two equations? Going to subtract. Remember, I'm trying to cancel A1s here, right? So 17 minus 93 is what? Negative 76 equals, then A1 minus A1 will go away. These cancel. That's what I want to have happen. And then 6 minus 25 is negative 19. Divide by negative 19. 4. So D is equal to positive 4. I would only plug it into one of them. But I've got D is 4, so this gets plugged into right here. So now I get 17 equals A1 plus 6 times 4. So 17 equals A1 plus 24 minus 24. So I get A1 equals negative 7. So now I have my A1 and I have B. Right? So I've got both things that I need for the formula. Now I can write the formula, which we will do. Just because this one's obviously a lot more work, but we've got AN is equal to A1 is negative 7 plus N minus 1 will stay there times D, which is 4. Double distribute. So I'm going to get negative 7 plus 4N minus 4. So it's going to be 4N minus 11.
Was this a lot easier than the last?
Because it's totally different.
That just sounds like-
What's the early part? It's only the second last name.
Very
Yeah.
Is there any reasons why we would plug it in?